Hello everyone. Today we're going to finish 16.2 day 2 and that is on solving exponential equations, and we're going to be involving real world problems with exponential equations. So let's take a look at the first example. By the way, this video is going to be very short, one of the shortest lessons, so hopefully you enjoy this 2-question video. Number one, suppose that $250 is deposited into an account that pays 4.5% interest compounded quarterly. And this is the equation here that gives the amount A in the account for n quarters for an initial investment P that earns interest at a rate of R. Solve for n to find out how long it will take for the account to contain at least $500. So using the equation on top, we know that A is going to be 500 because that is our target amount. And the principal amount is 250, that is the initial amount, times 1 plus the rate is 4.5, that converts to 0.045. Divided by quarterly means 4 times a year, and then raise it to the n power. So given this equation, we can actually solve for n now using algebra, because we've been dealing with algebra solving for the logarithm. So we're going to divide by 250 first on both sides to get rid of that 250 to make the problem a little simpler. And we have 1 plus 0.045 over 4 and then to the n power. This is actually a number here, so we can just use our calculator to crank out the answer. It should give us the amount of 1.01125 to the n. And from here, we can actually use our algebra skills to solve this by taking the log of both sides. Remember, log or natural log is fine. And again, this n goes to the front, so we have n log of 1.01125 equals log of 2. Finally, we're going to divide by the log of 1.01125 on both sides. And that will give us n by itself, which is this right here. And then using calculator to help us get the answer, you should have n is equal to approximately 6196, and that's in quarters. So to convert this into years, we're going to divide it by 4. That will be approximately 15.5 years would be our answer. Notice that another way to solve this is actually to enter the equation right here and set the left side to y1 and the right side to y2 into the graphing calculator, and you can find out where they meet, which is also gives us the same answer that matches the answer that we got from algebra. So it's 61.96 quarterly or 15.5 years, and that is the answer. And you can go ahead and try this next problem before you look at the solution. Hopefully you've had a chance to try the problem, and the problem says Sabrina deposits $4,000 into an account that earns 5% interest each year. The growth of the investment can be expressed by the equation right here, and where A is the amount after T years. In how many years will her account exceed $10,000? So we want A to equal to 10,000. That is the target amount. And initial amount is 4,000. 1 plus 0.05 to the T power. And notice that this is a simple interest earning 1 per year, so we don't need to divide by the number and compound. It's just 1 time a year, so that's why we just have 1.05 as the base. So to make the problem a little simpler, we're going to divide by 4,000 on both sides, and that will give us 2.5 equals, and we can combine the 1 plus 0.05 gives us 1.05 to the T power. And again, to solve this algebraically, we can go ahead and take the log or natural log of both sides and bring the T forward. So we have T log of 1.05 equals log of 2.5 divided by log of 1.05 on both sides. That will give us the answer, and we can go ahead and use the calculator. This is our exact answer right here, or we can approximate it into the calculator, and that'll give us 18.8 years. Notice again, you can also solve this using graph, and where they meet is exactly the same answer as what we have using algebra. So that is another way to solve it. And that's the end of the second problem. And let's take a look at the discussion problem. Describe the methods you have learned for solving exponential equations. And so we have actually learned to take logs of both sides and then use properties of log to evaluate. That's what we learned using the algebra. And another way is, of course, use graph. Use the graphing calculator. That would be another way, as we have demonstrated in this problem and the previous one here. And that is a wrap for today. So you're going to go ahead and get started with your book set, finish your HRW, and don't forget Alex. Have a great day.